Okay. Just a reminder, calculators, let's have them out. Let's have them out. Let's have them out in front of you here. I can't start unless we all have the calculators in front of you. If you miss class, your name will be up on the board showing you what Regents problems you missed, and then you owe them to me the day you get back, all right, or sometime I'm going to ask them about you. All right, so Mary, you got 1 and 3 for me. Okay, I just didn't get your name up on the board yet. So when you get those done, show them to me. Okay, and I'll ask them about it too. All right, so just don't circle somebody's notes. All right, everyone ready? Number 4. You got 2 functions. You have this one, 3x to the third plus x squared minus 5x, and then you have m of x, which I've graphed here. All right, we got to answer questions based on both of them. First question, because all these answers involve that term right there, the roots. All right, roots are another name for what's anybody? Another name for the roots? You could also see what word? Art? Is that the x-intercepts? I like that. Yep. Other terms? Anybody who's going to give me here? Zeros. Is that what you're going to give me, Lily? Yep. Zeros. They're your solutions. So if you look at the one they provided, how many solutions does it have? How many solutions? 2, right? Because it crosses once, twice. So m of x has 2 solutions, so I can get rid of which choices right now? M of x, this is the m of x graph below. So which choices can I get rid of right now? 3 and 4, because that says 3 and 4 roots. Okay, so that's gone. So now I got to figure out the one they gave me, 3x to the third plus x squared minus 5x. How many roots does that have? All right, how many roots? Is it going to be 3 or is it going to be 1 real root? Okay, some of you guys know it already. How can you just look at the equation and know how many roots it's going to have? Ashley? Highest exponent. Yep, so the highest exponent is 3, so that tells me it's going to have 3 roots. Okay, another way of doing it, how'd you find out? Graph it. Yeah. Equals on your calculator and graph it. And then see how many times it crosses the x-axis, and it should cross 3 times. All right? Everybody good? Questions there on roots, finding it on a graph, or just knowing before you even start the problem how many roots there are? We all good? I don't know, the last 3 we've done so far haven't really involved too much math, huh? And you've already gotten 6 points. Unfortunately, though, on this next one, we are going to have to start doing some math. Number 5. All right. Which one's equal to that one? I always open it up to you guys anywhere you think you want to start. Whoops, sorry. Wait. Where do you want to start on this one? You're taking that whole top one and dividing it by x plus 6. Ashley, go ahead. It's just thoughts. Even if it's wrong, who cares? You're taking a shot. Okay, I could do long division. Yep. Everyone remember, you probably don't want to remember, but remember doing those? And boy, there was a little bit quicker way, maybe after you learn long division, which you can do it that way. I have no issues with that. What's up, Jenna?
You can pick a number and then store it, and then you can see if it's equal to that.
You could do that. Yep. You take a number, store it in for x, find out what this value was, and then store that same number in for x here, all the 4 choices, and see which one are equal. Yep, that's fine. We talked about storing it again. What do you got over there, Lily? Anybody remember synthetic division? Okay. Yep, that's the way I'm going to show it here. All right. Because it is multiple choice, if you do get desperate, I shouldn't say desperate. If you forget about synthetic division, use Jenna's option, which is pick a number, store it in for x, and find out what you get here on top, and then see which multiple choice matches it. All right. But I do have a feeling you may have to do this non-multiple choice as well. So synthetic division, let's remember the little box in the corner. Anybody remember what number in this case should go there and where you get it? You look at the bottom, it's x plus 6. You plug in the opposite, which is negative 6. And then along to the right of it, you start listing out some numbers. Come from your numerator. The numbers in front now, the coefficients. So start listing them for me here. What do we have? 2, 8, negative 25, negative 6, and 14. Now, just be careful because this Regents, there's so many ways you could get trapped. Let's just say that 8x to the third wasn't there. You got to plug a 0 in for it. You can't just skip over it, okay? So watch out for that. If an exponent is not represented, you need to fill it in place with a 0. Okay, good deal, good deal. All right, here we go. First step. Drop the first coefficient down, 2. What am I doing with that 2? Multiplying it by the number in the corner there, which so 2 times negative 6, negative 12. 8 minus 12. Here we go. Multiply. Negative 4 times negative 6. Oh, negative, positive 24. Negative 25 plus 24. Here we go. Times negative 6. And I have a feeling many of you would want to stop there because you saw a 0, but we got to keep going. Multiply. 0 times negative 6. 14 minus 0, 14. What's that last one represent here? That's your remainder, 14. So it's going to be plus 14 over, anybody remember what you put it over? At the denominator, x plus 6. What's up, Art? Had a question? You're going to answer that for me.
No, I got a question.
Yep.
So, if you said that, like, the example we took away the 8x.
Correct. It would be 2, 0, negative 25.
What if there was no 14? Like, no x?
That's a good question. Because I don't know the- If there's no 14, would you put a 0 in for it?
Pretty sure you would.
Call Mr. Steena, he knows.
Let me look into it. That's a good question. Okay, seriously. I don't want to say, my gut would say it doesn't matter because it's at the end and that's it. But
But then when you put the, like, when you're placing the x's, when you put it
what's
you
that?
know how, the
Yep.
14 is the remainder, and then you skip the next one, and then you put an x on the negative one.
Mm-hmm.
You know what I'm talking about?
Yeah.
Like, if there was no 0 there, when you mess up the, because you would think that the 0 is the remainder, so then you put the x on the negative 4, so it mess it up. Right? If you need a place.
I don't know. I'll have to look. Yeah.
And if there wasn't a negative 6x or a 14, do you have to finish it and get that x to the 1?
Okay, I lost you there.
Like, so like, I don't know how to ask this right. If you didn't have the negative 6x or the plus 14, so you don't go all the way down to x to the 1.
You have to put
Then you have to put a 0.
Then you have to put a 0 there.
Yeah.
But if you already went down to x to the 1, then like
Mm.
the last number, like plus 14, it has no x, so you wouldn't have to put the 0.
That I don't know. That's what I got to find. But yes, you definitely would have to put in for x to the first. Yes.
Even if it didn't have the 14.
Well, if it had the 14, there's no doubt you got to put a 0 there.
Yeah.
Like you're saying, if I get just get rid of that, you got to put a 0 in for that. Yes.
Yeah,
But now you're saying no 14 as well.
so you
I'm still saying put in the 0 there.
Okay.
Okay. Everyone all good? Questions there? So this ends up being, if I had to write, I know it's multiple choice, so it's very easy just to circle 3. But remember, since it started off with x to the 4th, you start out with 2x to the 3rd minus 4x squared minus x. Okay, if you had to write it out, because I've seen a couple part 2 or 3s where you got to show your work doing that. Questions with you guys there? Good questions coming out. I'll find the answer today. Anything else? Okay, put your regents away. That's all I got time for today. Okay, quick review, and I'll answer any homework questions you may have had. We had something brand new on probability on Friday. All right, definitely want to catch up if you weren't here on Friday. Here we go. The P4, probability of A. What did this vertical line mean? Okay, what's the probability of A if B has already occurred? And how do we find that now? How do we find that? What goes on the denominator here to find this probability of A even though B has already occurred? What goes on the bottom? What is already given in this case? B. So probability, whatever B is, goes on the bottom, whatever's given. And then here's the important part, what goes on top? Whatever they had in common, A and B. And then anybody remember our new symbol for and? Upside down U here, yep. So whatever they had in common. All right. Questions there? Going. Art, go ahead. 3? The rain one?
Yeah.
Okay. Okay, here you go. First one, part A, probability it rains given it's already snowed. So I know given that it's already snowed, should go on the bottom. So as I read through the problem, as you read through it, what are the chances that it snows?
18.
18%, right? So I can keep 0.18 on the bottom, sorry, because that's what was given. So 0.18 on the bottom. On top would be rain and snow, the chances. So rain and snow, we have 4%. So 0.04, and then I calculate it that way. Good? Okay, now why is B different? Well, now it's probability of snow given it's already raining. So what's my new denominator, Art? What's the probability that it's raining already? 0.12 on the bottom now. And then what's still on top? Snow and rain, which is what? 0.04. Okay? Good? So again, on the bottom is the probability of what's given, and on the top is the two put together, the and. All right? Going to work on that more today. Others, that anything else while we're here? Yes? 4A. Perfect square given it's even. All right, so on the bottom should be what's already been given. Even. So I look how many even numbers. Now, it's not going to be out of 8 anymore. It's going to be out of, how many evens do I have? 4, right? So now this is not out of 8, it's out of 4. Because I already know it's even. Everybody good there? It's been given it's even. So now, Lily, here I go. Out of those evens, how many are perfect squares? Which ones are perfect squares? Well, 2 is not a perfect square. Perfect square means I can take the square root of it. So right, can't take the square root of 2. 4 is a perfect square. 6 is not. 8 is not. So there's only 1 out of the 4 even numbers. We good? Yep, go.
For that, we own. No,
Go ahead. What?
no, I'm gonna think it's fine.
Okay. Anything else here? Are we okay on these givens? Because not only is it big for Wednesday's unit test, but if the Regents is going to ask a probability question, it's probably going to be one of the given ones. Okay, if the Regents is going to ask some sort of probability question, it's probably going to come in the form of the given type. Anything else here? And remember, Wednesday, you got your unit test. Go.
The last test before break?
Probably. I don't know when I give the first one in the last unit, but probably. Anything else? Okay, let's go to today's notes. Last topic here I got to go over, and that is how can I test if something's independent or not? All right, real quickly, help me do this one. This is just a little review, but it'll lead into perfectly what we got to do today. I'm going to deck a card, so I get it. All of us don't know the deck yet. You're going to pick a 10, then a heart, but I'm not replacing the first card. What's my probability here? Okay, so let's go pick a 10 first. What do you got for me? Pick a 10. How many 10s? I just want to know the probability. I pick a 10 out. 4 out of 52. Okay, I do not replace it. I do not replace it. What's the probability I then pick a heart now? I should have made this better. How about this? Because this is going to get complicated. How do you know if that's not? Ready? 10. I picked the 10 of spades out. Good?
What is that?
All right, let's do this. Sorry. Let's do this again. Pick a 10 of spades. What's the probability? 1 out of 52. I just picked the 10 of spades. What's the probability I pick a heart now? 13 out of why 51? Okay, I took 1 out. So everyone good? Was this called these two events independent or dependent? This was dependent, right? Why was it called dependent? Because the second probability depended on what I did first. And when did I call it independent? If I did what? If I replaced it. So anytime I replace, I call that independent. What if the problem does not involve replacing one bit? Okay, but I still want to know if it's independent or not. Go ahead, read through my brake pad example. So needing transmission fluid and needing brake pads, are they independent or dependent of each other? All right, I don't know because I'm not replacing one or not replacing like the card example. Everyone agree? So what I got to show you today is how can I tell from a problem if these two events are independent or not? Okay, I'm going to start with the conclusion first and then we'll apply it to the problem. So if two events are independent, okay, if two events are independent, you're going to perform the following tests. The probability of A times the probability of B will be equal to the probability of A, and what's my symbol there again? For what? What's that the symbol for? And B. Okay, so when I multiply the probabilities, it'll be the same as if I did the and. Guys, go down to the brake pad example. Now, go down to the brake pad example. This is how we're going to test if brake pads and transmission fluid are independent or not. So here we go. What's the one thing? I'm testing two events now. If they're independent, what's one event? What's the one event up here? I'm testing if two are independent or not, but what's one of them? Okay, brake pads. I'll do a B. Is that all right? If I do B for brake pad. So is the probability of brake pads times, what's the other one I'm testing with it? We'll call that T. Is that all right? That should be equal to what if they are independent? The probability of getting brake pads times the probability of transmission fluid should be equal to what if they are independent? It should be the probability of B, brakes and transmission. If they are independent. If they're not equal, guess what? They're not independent. So I'm just going to draw a line down here. You don't have to, but I'm just going to draw a line down so I can compare the two. Where do you find all these probabilities? In the darn problem. Okay, so somebody reread it for me. Probability I need brake pads. Here we go. Probability I need brake pads. 2. What's the probability I need brake pads? It's right. You just got to read through there. Nick, you got to read through. So ready? Point. Yep. So ready, everybody. 0.28 times transmission fluid. Find it in the problem. 15 transmission fluid. Point. I believe that's the both one. So transmission fluid 0.38. And I'm going to ask myself, use my calculator, is that the same as the probability of brake pads and transmission, which was given in the problem as what probability? 14. 0.616. You guys figure that out. All right. I gave you the probabilities. Now you got to do it on your own to see if they're equal to each other. And what do we end up with? What do we get here? 0.1064. Is that equal to 0.16? No. So are they totally independent of each other? No. One depends on the other, right? You getting brake pads depends on if you need transmission fluid. All right, so these events are dependent on each other. See why? This is the test I want to have every single time. All right, that's the test I want every single time. Questions from you guys? Going. Okay. Here we go. One doesn't make you great. Okay. I just want to do and read it for me. Probability of Brown eyes, what's the vertical bar for? Oh boy, come on, it hasn't been that long. Probability of brown eyes, given they already have blonde hair. So we already know they have blonde hair. Okay, I already know they have blonde hair. So all I need is, what's this going to be out of then? Don't yell out anything. We already know they have blonde hair. So this should be out of what? 1. We already know they have blonde hair. So 0.35. This is the only column I'm looking at. They already have blonde hair. So it's going to be something out of 0.35. Brown eyes from those blonde-haired people. Brown eyes. 13.1. Yep. Now leave it like that. Let's clean that up a little bit. Leave it as a fraction if you can for me. And what do we end up as a fraction for that one? Here you go. 1, what do you got for me? Two out of 7. Everyone all right on how we did that? Look what we did. We put blonde on the bottom because that was already given. And on top, what did we put? Brown and blonde. Isn't that exactly what our formula says? What's given on the bottom, the and on top. All right, one more just to make sure we're good. Probability of red hair given you already have green eyes. So I'm not going to say a word here. What do you want on the bottom? Here we go. Probability of red hair given you already have green eyes. 11, what are we putting on the bottom there? What's already given? What's already given to you, Olivia? Probability of red hair given. Oh, you're 4. Okay, never mind. Used to be 11? No. Okay, never mind then. No idea. Who's 11? We're just going to stay in silence? Okay. Sorry, Olivia. 3? What's going on the bottom? 0.25. That's given green eyes. 0.25 right there. And then on the top, red hair. 2. Red hair, 0.15. Yep. Those green-eyed gingers stealing souls. Sorry. No, it's just, I do that every year. Sorry for any former redheads or whatever. You got a reputation. What?
I was wondering if anybody in here.
Even if they did, who cares?
Because you said former,
Okay.
so it's like, did anyone?
Or current, I guess I didn't see a.
Is that your natural hair?
Yes, it is. No, it used to be red. Yeah, it's got the lettuce trimmed. 13. 13. What do we have as far as the final probability? Yeah, 13. That's the number I called. Okay. 0.15 divided by 0.25, turn it back into a fraction. 3/5. Yep. All right. Now to today's stuff. Does having red hair depend on having green eyes? I have no idea. But I could test if they're separate. I have a test to see if they're independent, right? Yes.
So
And by the way, this is mathematically. This is not your opinion, by the way. All right, this is mathematically proving to me that one depends on the other. Go ahead, Ashley.
2 things. 1, can you like just put 3/5, not like 0.3 over point?
No, I want it 3/5.
So how
So in your calculator, you do 0.15 divided by 0.25.
But she means like, why is it not a decimal?
Oh, you can leave it as a decimal, sure. What do you mean, 0.6?
No, she means like 0.3 over 0.5.
Yeah, because that's
Yeah.
what I wrote for the first one.
Clean that up.
Okay.
No,
and then
clean that up.
also, you're saying that this, like, the second one, like, C isn't an opinion thing. So are these, like, real stats?
I don't know where they came from. I'm sorry. But mathematically, based on this information, I can prove to you if having red hair depends on you having green eyes or if they're totally separate.
But by these stats.
Yes. Correct. Okay. All right. Again, I don't have a test to tell you whether they depend on each other, but I can test if they're independent, right? And that's what I gave you at the beginning of class today, which is, what are the two? First, I need to ask somebody, what are the two events we are testing right now to see if they're related or not? What are the two events I need to test? Oh, 9, where are my two events? Okay, so ready? Probability of red hair, and what's the other one? Times the probability of green eyes. If they are independent, what should that be equal to? What's our test? Probability of red hair times probability of green eyes should be equal to the probability of what? Probability of red and green. If they are, that's what we're testing right now. I have no idea if this is true or not. I need to plug in the numbers. Okay, so off your table, probability of red hair. From the table, what's the probability of red hair? From the table. 3, what's the probability of red hair from the table? Point. Remember, just red hair. This is just straight up red hair. Yep, the whole thing. 0.20. So does 0.20 times green eyes now? I didn't say green with this or green with that. Green eyes total. 4, what do you got for me? 0.25, yep. And I'm going to see, does that equal, using your table, what's the probability you have red hair and green eyes? Find the intersection. 8, what do you got for me? 0.15. So you guys got to do that calculation. Does 0.2 times 0.25 equal 0.15? What do you get? What's 0.2 times 0.25? Point. Not equal? Now, be careful. Think about this when I ask this, please. Do they depend on each other? Yes. Yes. What did we just prove? They're not independent. We just proved those two are not separate from each other. So yes, having green eyes depends on having red hair. Somewhat.
Mr. Carliano, can you do Punnett squares? You know how to do a Punnett square?
No. And where did that just come from?
Because that's like genetics. That's like red hair.
Oh, the little square with the 4 things
Yeah.
and XY chromosomes and no, I can't do those. I just know of them. Like you got a 25% chance of this or 50% chance of that. All right.
Wait,
Okay.
I have a thing.
Okay, I'm moving on.
No, it's important. Mr. Carliano?
Yeah, go ahead. I'm listening.
Alright, so did you know that even if, like, you, or, like, the person you're having babies with, like, doesn't have brown eyes, like, if your, like, mom or something didn't have, like, brown eyes, then the kid could have brown eyes.
I was not aware of that, but thanks.
Isn't that crazy?
That's unbelievable.
Yeah.
Wait, what did you say?
Yep.
Nearly unbelievable. The probability of that not believable.
Yep.
is low.
You're on. That's right, Ashley. Great job.
That's crazy.
It is. You're right.
Oh my god.
Good work. All right, here we go. Let's go to the classroom now. So I have male, female, and then I have all the subjects there, all right, and what they prefer. Okay, what their favorite subject was and how many of them. Does it appear based on this data that there's a preference for math as a subject depending on a student's gender? So 2 things we're testing right now. Math and student's gender. So we're gonna have to do this twice, right? We're gonna have to do it 1 for male, 1 for female. Okay, so let's do the male one first. If you like math, does it depend on if you're male or not? Okay. So what are the 2 things I'm gonna test here? To see if male and math are independent or dependent here. 2 things I'm gonna test.
The total of people, total number of males that like.
Okay, so probability you're male times what? What's the other thing I'm testing with it, if it's independent or not? Math. So the probability, I probably should have just written out male, but there you go, math. And we're going to see if that's equal to what? If they are independent, it should be equal to the probability of, we've been just doing it all day, male and math. Okay, let's see. If they're not equal, then yeah, they depend on each other. Here we go. Using the table, 3, using the table, what's the probability you're a male? Okay, but that's, now we're doing probability, right? 27 out of 57, there we go. Everyone all right where that came from? 27 out of 57, you're a male. All right, what about you like math? 6?
Oh, you're male and you like.
No, just math. Probability you like math.
It's gonna be 18.
Out of?
57.
Yep, here we go. Multiplying those, that should be equal to male and math. How many you got for me there? 10, how many you got for me there? Male and math. Not here. Just read the table, Ben.
Oh.
Yeah, don't do the crunching the numbers yet. I just need probability, male, and math. That's it, boss. 10 out of 57. All right, let's see if they're equal. See if their decimals are equal. That's all I'm looking for here. See if their decimals are equal. This or the given ones. Yep. What are you guys finding? Equal or not? Left side equal to the right side or no? Nope. All right. Here's the thing I got to harp on is, what did we just show? By showing they're not equal. Meaning, well, being male anyway, depends on if you like math or not. Okay? We still got to do female, right? Okay, here we go. Female. The only thing that's going to change is the probability you're female. That's it. So instead of 27 out of 57, what do you have instead? 3. What do you got? Female. So does 30 out of 57 times 18 out of 57, is that going to equal 10 out of 50? Oh, sorry, that's not going to be 10, is it? Female and math, how many you got there, Brett? 8 out of 57. Equal to each other? Anybody finding if they're equal? Nope. So what can we say about gender and math here? They are dependent on each other, yes. Gender and math are dependent on each other. Are we ever going to get an independent one, you ask?
The next problem.
One depends on the other. All right, what about social studies now? Social studies and gender. Do they depend on each other or not? Here we go. Same thing, right? I got to test the male and the female. All right, now just so we can go a little quicker now. All in one now, what are you going to test? What are the probabilities you're going to test? I think you can handle it. Male times social studies. Does that equal math, male, and social studies? So ready? Let's start now. Male. 2. We already did this part. So male. Who's got 2?
Um, 27.
27 out of?
57.
Okay. Times social studies. According to the table, social studies now.
19.
Is that equal to the same probability as male and social studies? How many you got there for me? Where's that intersection, male and social studies?
9/57.
Go ahead and test that. And what do we find there? What's, yeah? They're equal, right? Oh, look at that. You liking social studies has nothing to do with you being male. What about female? How many females were there? 30 out of 57 times, what are we going? 19, right?
Yeah.
Out of 57. How many females like social studies? 10 out of 57. And you would find out same thing. So does being male or female have any effect on you liking social studies? Nope. These are independent of each other. And I will do that last problem with you tomorrow. Again, tests on Wednesday.